how long do you want to be around? Voyager 1, the ancient probe, has done it again. In the boundless, mysterious expanse of interstellar space, this resilient spacecraft has proven that, despite every challenge, it still stands as humanity's most reliable outpost. But this time, the stakes were higher than ever before. NASA's engineers had lost contact with Voyager 1. Technical issues had taken their toll once again, and the team had to scramble for a solution. This wasn't the first time. In fact, these kinds of problems have become almost routine for the aging spacecraft. Yet, against all odds, a forgotten piece of technology, something obsolete for decades, would become the key to saving the mission. The backup transmitter, untouched since 1981, fired up just when it was needed most, allowing the space veteran to once again phone home. Imagine this. When it's cold outside, it's easy to just flick a switch and turn on the heating. But out there, in the boundless depths of interstellar space, things are never that simple. Voyager 1 has been journeying through space for nearly 50 years, surviving technical setbacks that would have grounded any other mission. It should have been a routine task, turning on one of its heaters. But what happened next sent shockwaves through NASA's operations. On October 16th, after sending the command to activate the heater, the team waited for the response. But 2 days later, they were met with silence. Voyager 1's signal had vanished. They waited in agonizing suspense, unsure of what had gone wrong. The distance was simply too great. The probe had been 24.7 billion kilometers away for years, and it takes 23 hours for a signal to travel that distance. But what exactly happened? Like any great explorer, Voyager 1 is equipped with a fail-safe system, a safety net for when things go wrong. This system is designed to conserve power by shutting down non-essential functions, and on this occasion, the heating command triggered the system. Although the spacecraft had enough power to run the heater, it wasn't just the heater that went offline. The X-band radio transmitter used to communicate with Earth also shut down. With the clock ticking, NASA's experts did what they always do. They thought outside the box. They knew the risk. The X-band transmitter had been dimmed, and finding the faint signal it left behind would be like looking for a needle in a cosmic haystack. But then a breakthrough. A faint signal from the S-band transmitter. The S-band, the backup, the relic of the 1980s, had been abandoned years ago. Voyager 1 hadn't used it to communicate since 1981, when it was still exploring the far reaches of Saturn. At the time, it was only supposed to last 5 years, but somehow, against all odds, they found it. NASA engineers were faced with a life-or-death decision. Should they risk turning the X-band back on, knowing that the fault protection system could shut it down again? Or should they stick with the fragile S-band signal, even though it was weaker, older, and never designed for it? It wasn't an easy decision, but they decided to take the risk, because sometimes that's all you can do when you're pushing the boundaries of what's possible. On the 24th of October, their gamble paid off. A stable connection was re-established. The backup transmitter, which hadn't been used for more than 40 years, had saved the day. But the story doesn't end there. Despite this incredible triumph, it's clear that Voyager 1's journey is coming to an inevitable end. Its instruments, once the pride of human engineering, are showing the wear and tear of decades of space travel. The signals are fading. The systems are faltering. The probe is reaching the limits of what was ever expected. But even the most resilient creations must eventually succumb to the ravages of time. NASA's mission was only supposed to last 5 years, but Voyager 1 has defied the odds, surviving nearly 10 times longer than anyone could have imagined. How did it do that? By carefully managing every ounce of energy, systematically turning off non-essential instruments, and relying on backup systems like the S-band transmitter that saved it today. But the energy-saving plan has its limits. What happens if something goes wrong? If something vital fails? Voyager 1 relies on thrusters, tiny bursts of liquid hydrogen, to point its antenna and maintain its link with Earth. Once pristine and reliable, these thrusters have suffered the ravages of time. The nozzles have clogged up over the years, and deposits have built up in the fuel lines. NASA was forced to switch to a spare set of thrusters long ago, and now in 2018, The third set, originally intended for course correction, is showing signs of wear. Now the situation is more critical than ever. Nozzles are clogged, lines are narrowing. What was once a generous 0.25 millimeter opening is now just 0.035 millimeters, smaller than a human hair. Every day, the team faces the possibility that these engines could fail, and if they do, NASA could lose contact with the farthest spacecraft ever sent by mankind. To make matters worse, Voyager 1's energy reserves are almost depleted. Any additional power consumption could mean the loss of a critical system. So, NASA had to make a difficult decision: shut down one of Voyager 1's main heating systems to conserve power for the thrusters. It was a gamble. Could they afford to shut down one vital system to save another? The team deliberated for weeks, poring over calculations and simulations. Finally, on the 27th of August, they made their move. The main heating unit was switched off for an hour, during which time the thrusters heated up just enough to allow Voyager 1 to point back towards Earth. For now. But how long will it last? Experts predict that by 2036, Voyager 1 will be out of range. The distance will be too great, the technology too old. But the clock is ticking, and with each passing moment, the NASA team is working tirelessly to extend Voyager 1's life just a little bit longer. The race against time is intensifying as each year brings the spacecraft further away from Earth. Every signal, every burst of energy sent into the vast, cold void of space is a testament to human ingenuity. But it also reminds us of the fragile nature of this mission, and perhaps of life itself. And so, as we witness this final chapter in Voyager 1's voyage, we are reminded of the fragility of time and the relentless human spirit that keeps pushing forward, no matter what the cost. This spacecraft has sent back more than data. It has sent back a message of perseverance, of the lengths to which we will go in the pursuit of knowledge. It has shown us the very essence of humanity's quest for the unknown and the infinite. But now, as we await the inevitable silence, we must ask, how far will you go to push the boundaries of the possible? How long will you keep fighting, even when the odds are stacked against you? How long will you hold on when the light is fading and the darkness seems to be closing in? What is your legacy, your lasting impact on this world? Every second that Voyager 1 continues to send signals, it's more than just science. It's a reminder of our own power, our ability to defy time and space, to go beyond what we thought was possible. This isn't just the story of one spacecraft. This is the story of every one of us who dares to dream, to reach, to explore. And before you go, don't forget to click the subscribe button. Voyager 1's story is far from over. Its whispers from the edge of the solar system still echo through time and space. Join us on this extraordinary journey and stay tuned for the final moments of mankind's most ambitious exploration. We'll see you soon as we continue to reach for the stars.